Okay, hello again, grade 10s. This is our third part lesson on light and plane mirrors and looking at the law of reflection. And now we're going to look at how you can figure out and describe what an image looks like inside of a mirror. Okay, so here we go. We're locating an image in a plane mirror. What does that mean? It's like if I have a pen and I'm looking at the pen in the mirror. This is the object. What I see behind the mirror, projected behind the mirror, is my image of a pen. Okay, and can you describe that image by a few characteristics? That's what this lesson's about. All right, so number one, the incident light rays are reflected from an object onto the reflected surface. So you have to remember that when your eye is looking at this object right here, so if I've got a pen, for example, in front of the mirror, it's the light that's traveling, right, off of this object into my eye at a particular angle because I can see this pen, right? How can I see it? I only see this pen because there is light in the room, right? Turn the lights off, completely dark. I can't see the pen because I don't have any light. If I set up a mirror, how does my brain see this object? It sees it as an image, as if it's projected behind the mirror. This is where optics gets a little crazy because sometimes it's hard to even think about that concept, right? Again, this is the pen, this is the object. I see the pen in the mirror, but that's not the object. That is the image, okay? That image tells me something about how the light reflects from this object and my eye off the mirror, and my brain projects it behind. So I see this pen in the mirror, grab a mirror and actually put an object there, and it looks like it is behind the mirror. Like it looks like I could simply go behind the mirror and catch it. Right? Why does it do that? It's because my brain projects it behind the mirror and I can figure out what that image looks like based on how the light rays travel, because light travels in straight lines and there's a rule about how light bounces or reflects off of a mirror. Okay, so here we go. The incident light rays are reflected from the object onto the reflected surface. That is our plain flat mirror. At the mirror, the angle of incidence blanks the angle of reflection. And you remember what this word is? It equals the angle of reflection. Which angle? Remember, the angle of incidence is the angle between the incident ray and the mirror and the normal. And the angle of reflection is between the normal and the reflected ray, okay? Those two are the angles that are equal to each other. The eye then receives the reflected ray. Can you see that on this diagram right here? Your eye receives the reflected ray, and the brain projects the reflected rays behind the mirror in a straight line. Now, in actual fact, this pen that you can see on the diagram right here, we're only taking a line from the top of the pen and a line from the bottom of the pen. This would work no matter where the light is hitting the pen, all the way up and down it, okay? But you can figure out the image where the top of the pen and the bottom of the pen are behind the mirror if you just have the top and bottom of the object, because I can just fill in the rest. I know what the rest of the pen looks like. If I know where the top is and I know where the bottom is, I can take this point right here, that point right here, and draw my pen. Okay? All right, number 4. The results in your brain thinking that there is a light source behind the mirror, and this image is something that we call a virtual image. Okay? It is a virtual image. A virtual image means that it is not real. Okay? It is not real. This kind of image is behind the mirror, which means it's not a real image. It's an image, but it's not a real image. A real image is one that I could capture on a screen. Okay, so could I take that image and put a piece of paper there and capture it? No, because the image is behind the mirror. If I was looking at lens and mirrors that happen to be inside of a movie projector, and I'm putting it towards a screen, those images can be captured on a screen. It's like how a photograph works. And then we call those images a real image. So I just want you to use that as your definition of what a virtual image is. A virtual image is not real because it can't be captured on a screen. It really means that the light does not focus in front of the mirror, because if those beams of light right here and here, where they come together and focus and meet, if that happens in front of the mirror, I can capture it with this piece of paper or a screen, and the image will look exactly like it is there. Okay, this is why it's very tricky to teach optics virtually, because I guess I'll just have to find some simulations to show you what that would look like. If we were in the lab, I could do that because I have some curved mirrors where we can actually capture the image. Okay. All right, so remember, we're still just looking at flat mirrors for today's lesson. Now, let's use equal and perpendicular lines to figure out where that image is behind the mirror, okay? So when you stand in front of a plain mirror in your bathroom, you may notice that the writing on the front of your shirt may seem backwards. By choosing enough points on that object and drawing a series of incident and reflected rays, you can actually demonstrate why these images appear backwards in the reflection. They are behind the mirror. This time, what I want you to draw is a series of object image lines to where you would detect the image, and I want to consider two different things, okay? The distance between the object and the mirror is the same as the distance between the image to the mirror. Same on both sides, okay? I want you to look at this. As I move this farther away, it looks like my pen is farther away from the mirror. The closer you move your object to the plain flat mirror, the closer the image is as well, okay? The object image line is perpendicular to the mirror surface. So here we go. You notice that my object is completely drawn in. The image is ... because it's not real. You can't capture it. It's what we call a virtual image. The object is in front of the mirror. The image is the reflected item and is described by an acronym SALT. Hold on to that thought till we get to another page, and I'll show you what those letters mean. Okay? It means that if you had a plain flat mirror and you measured the distance between the tip top of the pen to the mirror, that is going to be equal, and here's where you need to use a ruler, okay? I'll sometimes just use my pen on the iPad, but watch this. I can actually hold it down and get a straight line. You would do the same thing, and I want you to see that the distance between the mirror and the object is the same as the distance between the mirror and the image. Let's take the very bottom tip of the pen, and the distance between the object tip and the mirror is the same. I've got little 4 hashtags there, 1, 2, 3, 4. That's just showing that the distance between here is the same as the distance between it on the other side, between the mirror and the image. Okay, if you wanted to be really specific and you were trying to draw this image, you'd notice that you've got your little pen cap there. So exactly how far is the tip and the bottom and top of this little pen? I'm not even sure what that's called. It is equal. Okay, that's the law. Equal, equal. If this is 2 and this one is 3, then they are all the same. Okay? All right, there's a few homework questions right here. I'm going to pause the video and then I'm going to come back to looking at how you describe that image.